Yes, thank you. So I'm going to talk about some of the results that I got during my PhD work, and a big part of the analysis I conducted was on library dependency networks in the iOS ecosystem. So first of all, let's say you're an app developer. You have some custom code that you're writing yourself, but since there are a lot of solutions to already existing problems, then you would like to use these libraries in your application. For that, if you're doing writing an iOS application, you have 3 different package managers that you can choose from. There is CocoaPods, there's Cartridge, and there is Swift Package Manager. And then the collection of that, because these libraries might also have dependencies to some other libraries. It could be that they are in the backend using some other package manager. Maybe you decide to use multiple package managers. So the whole ecosystem consists of the interaction of between using these package managers. There could be libraries written in Swift that you are using probably for iOS development, but the libraries could also be in Objective-C, in C++, in C, and all of that I'm calling the Swift ecosystem, just to have a good name for that. It's not all in that language, but let's say that this is the Swift ecosystem of all the libraries. CocoaPods was the first package manager. It was introduced in 2011. It has a central repository and an estimated number of 80,000 libraries in it. Then in 2014, a new package manager was released. My hypothesis is that since CocoaPods was quite heavy in the sense that if you are creating a new project that uses it, then CocoaPod generates a new project file that you have to use for your development. So you are a little bit restricted in how you're setting up your project. And Cartridge, on the other hand, is very, very lightweight. You have to do a little bit more work because the library is automatically downloaded and built, but you have to include them yourself in your project. So you have more control, but you have to do a little bit more work. So it seemed like there are quite different user bases for both of the package managers. Then in 2017, Apple saw that, well, package managers seem to be something that developers want to use. So they released the first official package manager. And although it was released in 2017, support for iOS was actually came actually in 2019, so it's a fairly new package manager, and it has gained a lot of features over the time, and now it's possible to use it quite easily right out of Xcode. That's the IDE that you normally use for iOS development. So Apple has tried to make it more convenient for developers. Both Cartridge and Swift Package Manager neither have a central repository, so you kind of have to find the libraries that you want to use yourself, for example, on GitHub, and then you can use the repository address to declare the dependency. Now, we have this quite interesting ecosystem in the sense that we have many different package managers that have been introduced over time. So I wanted to see, first of all, how the ecosystem has evolved generally. I was also interested how the library developers decided which package manager to use. Maybe they switch between them, how they use these package managers, and what kind of consequences this use could have, for example, for security vulnerabilities. So I posed 4 different research questions. First of all, looking into how the library dependency network has evolved, then how the package manager use has evolved, how the version requirement types influence library dependency updates, so to see how the use of these package managers affects the technical lag that these projects then could have, and lastly, what is the impact of that, and how do the vulnerabilities spread in this library dependency network. So for the first research question, looking at the evolution of the Swift library dependency network, well, it has grown over time, but compared to some other ecosystems where the growth is really exponential, it's a little bit different as it has slowed down over time. Also, when looking at the growth for each of the package managers, Swift PM is still somewhat growing, but it's not the normal expectations that it would grow exponentially, and at some point we're all full of libraries. And one of the explanations for that is that when we are going to developer forums or reading or Reddit, then iOS developers seem to be very skeptical of libraries. They just don't seem to want to use them too much, so it might be that at some point there is enough libraries for the ecosystem. There might be some new ones, but there is no exponential growth. And interestingly, when looking at the proportions of which package manager has most of the libraries, we see that SwiftPM is growing, but CocoaPods is still up there. The other thing I looked at for the growth of the library dependency networks was looking at how the number of dependencies has changed. For example, on NPM, it's a really big problem that an average library might have 40 dependencies, and these have dependencies and dependencies, so there are very big dependency change. In iOS, this is quite different. This is the mean number of dependencies going around 2, maybe up to 3. The median number was between like 1, 2, at some points maybe at 3. So basically, most of the projects use very, very small number of dependencies. Now, when looking at the transitive dependencies, there is a slight growing trend, but still there is not yet, there doesn't seem to be a big problem there. The second question, which I think was quite interesting thing to look at, because most other ecosystems, it seems like you have one main package manager, maybe something for a very specialized subset, but in iOS development, the CocoaPods cartridge and SwiftPM are not really specialized in specific libraries, but you can use them for pretty much completely like regular libraries. And I looked into how the migration between the package managers has evolved. The first thing that I saw was that most libraries are not using a package manager at all, which was a little bit surprising. The top number of libraries not using a package manager, or the smallest number of libraries not using a package manager over time was around 80%, so most libraries simply don't have any dependencies. Then the other thing is that development of most libraries is abandoned. We see that new libraries come in, but a lot of them just fall off. I don't have good reason for that. Maybe just people try to do something and abandon it, but the number is really high. And we also see that there is migration between all of the package managers. And to see that better, I zoomed the picture in a little bit, discarding all the libraries that are not participating in the migration. And we see that there is quite a big migration from cartridge to SwiftPM, which the reason could be that the package managers are fairly similar because they don't have central repository. They are both quite lightweight. And since SwiftPM is more easier to use and the official one, so it could be that developers decide to then move to the new official package manager. But the interesting thing was that CocoaPods is still quite popular, and maybe this is due to some of the more unique features. For example, if you look at which new libraries are using which package manager, we see that CocoaPods is still being picked, although it's a quite old package manager. We have newer, I would say maybe better alternatives, but it's still the most popular one even now. And my hypothesis is that it could be because CocoaPods has a central repository, which I think if Apple would like to make SwiftVM to be adapted even more by developers, they could offer central repository for the libraries. And actually, a couple of months ago, I saw that Apple started to support a web page that has a repository for libraries, not having the libraries, but having information on the libraries. So it seems like they are also understanding that users want to have that information in one place. As the third research question, I wanted to look into how these package managers are used. If you declare a dependency, you have to give a requirement. So, for example, I want to have a version that is at least 2.0. Or I'm saying that I want to have the exact version 1.3. And I looked into how that has evolved over time and how the choice of the requirement type affects the dependency lag. And as expected, if we have requirement types that are more restrictive, for example, if I say exact version, then the dependency lag will be higher. If I am more relaxed in the requirement, then the dependency lag will be smaller because I allow more updates. But what was interesting is that when we compare the different package managers, then actually the average dependency lag was very different between them. The average dependency lag was a lot smaller for Carthage than for CocoaPods, for example, and even when most Carthage users used more restrictive dependency types. And one of the reasons for that might be because the developers that are using Carthage maybe want to have more control over how they are including these libraries. And I also looked into vulnerable dependencies, so dependencies that have publicly reported vulnerabilities, and around 30% of these dependencies could have been fixed at the time by simply upgrading. And it was also interesting to see that around 3% of these vulnerable dependencies could have been fixed by even not changing the version that we want to use, but by just rerunning the package manager so that it resolves the version again. Then for the last point, I went into more detail on the vulnerabilities in the library dependency network. And the interesting thing is that although the number of vulnerabilities per 1,000 libraries is quite similar to other platforms, since there are so many less dependencies, the overall ecosystem is actually affected a lot less. For example, again, for the example of NPM, where almost every library has some kind of dependency to a vulnerability somehow, in iOS that's definitely not the case. And overall, of all the libraries, if you take however far the vulnerability might be, 456 libraries had dependencies somewhere to a vulnerable library version. I also looked into if there are any differences on the language of the library that the library is written in. First of all, it looked like most of the vulnerable libraries are written in C, so it might be like that's where the most problems come from. But actually, the libraries written in C didn't have that much of an effect on the whole ecosystem because they just had less dependence. Most of the influence came from Swift and Objective-C libraries, since there were a lot more libraries that had dependencies on them, and also by looking into how many of these could be fixed through upgrades on whatever level of dependency level we looked into. Quite a lot of them could have been fixed through upgrading, and we're looking into the last version of each library, then the percentage was even higher, how many could have been fixed through an upgrade. To conclude it, I first looked into the evolution of the library dependency network. Then I looked into the evolution of the package managers in the network. I looked into how requirement types affected the dependency updates. And lastly, how vulnerabilities spread in the library dependency network. And some conclusions. When you start developing an iOS project, I would say choose SwiftPM. It seems to be gaining the most popularity and seems to be the easiest to use. And when developing a package manager, it's best to provide unique features which would guarantee you more users, although now in this ecosystem, I think, since we already have an official package manager that developers seem to like, I think it would be quite difficult to get a foothold. When you're adding a dependency, try to use less strict version requirement types and rerun version resolution frequently. And lastly, please update your dependencies. So, thank you.
Thank you. Any iOS developers? Nobody? Any questions?
Thank you for your presentation. I have actually a question about foreseeing the future. Can you predict, based on your extensive knowledge now, what will happen in 5 years in that field?
I think even more developers will be using the newest package manager. I think Cartridge will pretty much die out. Cocoapods will still have their users, but I'm pretty sure that it won't live. Maybe it might still be living, but I definitely think that SwiftPM will take on more users. And since looking into how many dependencies there are, I think from the availability side, it's not looking too bad. And some other ecosystems, there are very big problems. I think here it's not as bad. And it's also possible to find the vulnerable dependencies. I actually created a tool that can be included into Xcode, so it's possible to, even if you don't want to update all the time, you can detect all the vulnerable dependencies. So I think the current situation is quite good.
You have kind of done the descriptive analysis, or you have analyzed, and strange question from me, have you also planned for some qualitative analysis?
Not planned.
Analysis or anything?
Not planned, but I think that would make sense. I read studies on other ecosystems, and people have given reasons why they don't want to update. I think it might make sense to maybe try out some solutions for that, and then see if developers are willing to change some of the ways how they, if they update or don't update. For example, there have been results that even if you tell developers that they have a vulnerable library version, dependency version, they say that they don't care. They pretty much say that, yeah, it might introduce new problems. I also found when I was looking into if my tool works, I contacted some developers of open source iOS applications, and 2 of them promised to look into it. Most of them didn't answer, I think. And I'm not sure if any of them actually updated the dependencies. So, yes.
And this was open source iOS projects.
Yes.
But most of the iOS is, I guess, closed source, right?
Yeah, but this would need different kind of analysis, because for Android it's easier. You can take the APK and do quite a lot of analysis on that. On iOS, unfortunately, you don't have it that easy. So it would need to have either access to some companies that would show how they're doing it, or develop some new tools that would somehow understand what dependencies are used.
Okay, let's hope that the companies will be in touch with you. Okay, thank you.
Okay.
Was there?
I was just wondering, did you see any examples of libraries where the development was effectively already dead for like a few years or even more, but the library itself was still deeply relied upon by other applications or other libraries?
I didn't look into it, but I think that at least some point, it's, at least in iOS, it's not possible to use the library anymore. The problem is that, I mean, right now Swift has become quite stable, but for the last years it was fairly new and it was very unstable, and it wasn't backwards compatible. So at some point Apple told you, if you're not using the new version of Swift, then you can't upload your application to the App Store. And now when you're using a dependency and that one isn't using the new Swift version, you can't build it. So I'm not sure, maybe now it's maybe a couple of years that you could maybe still run the code, but this creates a problem in that sense that very, very old code you can't use if you're not modifying it and updating it to the new standards APIs.
Okay, thank you very much.
Thank you.